Perfect. Okay, so using probability to make fair decisions. You can see over here on the left, we've got the practice highlighted in blue, using probability to make fair decisions. But there's also a video we could watch first. So what if we watch the video together? Would you guys be okay with that? I mean, it might be a little bit annoying. Let's see. Maybe some of you have already watched it. How long is this?
The birthday party stands inside a circle of 15 kids. He's going to choose a volunteer, and he wants each kid to have the same chance of getting chosen. Fair enough. Now, we have 3 methods by which he can do it. And let's just think about whether each of these methods are fair, where each kid does have the same chance of getting chosen. And if they're not, if they don't lead to each kid having the same chance of getting chosen, think about why that is the case. So method 1, the magician starts with the birthday boy and moves clockwise, passing out 100 pieces of paper numbered 1 through 100. He cycles around the circle until all the pieces are distributed. He then uses a random number generator to pick an integer 1 through 100 and chooses the volunteer with that number. Let's just think about what's happening. So there's 15 kids in a circle. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I planned that out amazingly well. I didn't think I would be able to fit exactly 15, but it worked out. So 15 kids in a circle, and then he's going to hand out pieces of paper. So he's going to, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this person's going to get pieces of paper 1 and 16. Now this person's going to get 2 and 17. You're going to keep going around and round and round until all 100 pieces of paper are going to get distributed. Now, something to think about is whether every child here is going to get the same number of pieces of paper. I encourage you to pause this video and think about that. If we just keep cycling around all the way to 100, does each child get the same number of pieces of paper?
So pausing. I wasn't paying attention to which one he was on.
Well, just think about it. In order to get the same number of pieces of paper, 100 has to be divisible by 15. We know 100 isn't divisible by 15. 15 goes into 100 6 times. 6 times 15 is 90, and you have a remainder of 10. So what's going to happen is all 15 kids are going to get 6 pieces of paper, and then another 10 of the 15 are going to get a 7th piece of paper. So they're not all getting an equal number of pieces of paper. So even though he's randomly picking an integer between 1 and 100, some of the students are going to have a higher chance than the other ones. The 10 that have 7 pieces of paper are going to have a higher chance than the other 5 who only have 6 pieces, who only have 6 pieces of paper. And so I would say method one is not fair. Let me write this down. Not fair. Sometimes life isn't fair, but in this case it's not fair. Where we define fair as the same chance of getting chosen, and that's because they don't all have different numbers of pieces of paper. They're not, all of the students are not equally likely to get picked. Let's look at method 2. The magician starts with the birthday boy and moves around, then moves counterclockwise, passing out 75 pieces of paper numbered 1 through 75. He cycles around the circle until all the pieces are distributed. He then uses a random number generator to pick an integer between 1 through 75 and chooses the volunteer with that number. So I encourage you to pause this video and think about whether this one, method 2, whether that one is fair. Well, method 2 is the same as method 1, except for instead of using 100 pieces of paper, we're using 75 pieces of paper. So what you think about is 75 divisible by 15. And 75 is 5 times 15 is 75. So in this situation, each student is going to get 5 pieces of paper. Each gets 5 pieces of paper. So they all have an equally likely chance of getting picked. And then he's using a random number generator to pick them. So they all have an equally likely chance. I would say method 2 is indeed is indeed fair. They all have the same chance of getting chosen. Now let's think about method 3. Method 3, the magician starts with the birthday boy and moves clockwise, passing out 30 pieces of paper numbered 1 through 30. So they're all going to get the same number of pieces of paper. They're all going to get 2 pieces of paper each. 15 children getting 2 pieces of paper each would be 30 pieces of paper. So that looks reasonable so far. He cycles around the circle until all the pieces are distributed. So everyone gets 2 pieces. He gives number 1 to the birthday boy, number 2 to the next kid, and so on. So that all seems reasonable, kind of consistent with method 2, except now instead of 75, it's 30. And obviously 75 was overkill. Even here, this is overkill. He just needs 15 pieces of paper. And he then counts the number of windows in the room and chooses the volunteer with that number. So the question here is the number of windows in the room, is it random and is it evenly distributed? So maybe you can make a case, depending on what building it's in someone's house, it's somewhat random on how many windows that house happens to have, the house that's happening to host the birthday party. But it's not going to be evenly distributed. Most, I don't know, there's probably some, if you were to sit and plot all of the houses that had a birthday party, you'd probably see it's more likely that they have 10 windows than 1 window, or it's more, and definitely more likely that they have 10 windows than let's say, than 30 windows, or even maybe 15 windows even. And so it's not going to be evenly distributed. This really isn't this is, every house, I guess, has a somewhat different number of windows, and the house that is happening to host the party seems to be somewhat random. But it's not going to be evenly distributed here. And I would say it's not a kind of a really good random number generator because it's not evenly generated. And so I would say method 3 is not fair. Not fair. The number of windows is not a really good random number generator. A good random number generator, we would want, say, number 1 through 75, where any of these have an equally likely chance of getting picked. It's somewhat random, the number of windows that building has, but they're not all equally likely.
Okay, so let's look at this assignment. A magician performing at a birthday party stands inside a circle of 15 kids. Is going to choose a volunteer who wants to have this kids get the same chance of getting chosen. So I happened to get on my practice the same exact question that he just went through, right? So he said 2 would be fair, but 1 and 3 would not be, especially if those are the same, correct? So this is the actual practice, isn't it? We're supposed to check the one that we think is fair. Oh, we're supposed to match them. Is that what's happening? I don't even know how this works.
You just move it up and down.
Okay. Oh, so put that one there. Cool. So method 1 was not fair. The papers cannot be evenly distributed because we had 100 papers and 15 kids, so there's some that get more than others. And then method 3 is not necessarily fair because choosing the number of windows or counting the number of windows isn't necessarily random. So I'm not sure that actually fits exactly what he said about it, but don't you feel like that's probably the closest?
Yeah.
And then method 2 is the one that's fair. So we're going to check, and we got it. And so we go to our next question. Last day of summer vacation, Jenny and her mom are trying to decide where to have dinner. Jenny wants to eat Mexican food, and her mom wants to eat Italian food. So which of the following are fair methods for making a decision? Jenny starts the timer on her stopwatch. She doesn't look at the watch for a few minutes, and then she stops the timer without looking at it. If the hundredths digit, for example, the 3 in 2 minutes 17.13 seconds is between 0 and 4, they eat Mexican. If the hundredths is between 5 and 9, they eat Italian. So I feel like the method of choosing that digit is pretty random. The hundredths place on seconds, it's going to randomly hit that number, right? So 0 to 4, that's how many digits? 0, 1, 2, 3, 4. So that's 5 digits for that one. And then 5, 6, 7, 8, 9. There's 5 digits for that one. So I believe A seems pretty fair, right? And we're going to choose all answers that apply. So we might not be done. Jenny starts the timer on her stopwatch. She doesn't look at the watch. She stops the timer without looking at it. The minutes digit, so the 2 in 2 minutes, 17.13 seconds is between 0 and 4. They eat Mexican. If the minutes digit is between 5 and 9, they eat Italian. Now, I feel like that one's probably not fair because she probably has a general idea without looking or paying attention to her watch if it's been 2 minutes or if it's been 7 minutes, right? So that one doesn't seem as fair because then she could make it lean toward what she wants instead of what her mom wants. Okay, Jenny and her mom have been at the pool all day and they don't know what time it is. They know it's at least 2:45, but before 3:45 because the 10-year-olds are having swim practice. They decided to check the time on Jenny's mom's smartphone. If the minutes digit, for example, the 6 in 806 is even, they eat Mexican. If the minutes digit is odd, they eat Italian. Okay, so they know it's between 2:45 and before 3:45, but I'm not entirely clear if that includes 2:45 and 3:45. It seems like it's fairly fair, but I guess there's a possibility that in that time frame, it could be like an additional odd number or an additional even number. Does that make sense? So I'm questioning that one. This is where these problems kind of get difficult and we start getting lower scores is because they're really close, but maybe not. I'm on the fence with that one, so I'm going to have you guys weigh in and help me with that in a minute. Jenny and her mom have been at the pool all day. They didn't know what time it is. They know it's between 2:45 and 3:45. They decided to check the time on Jenny's mom's smartphone. The hours digit, the 8 in 806 is even, they eat Mexican. If the hours digit is odd, they eat Italian. They don't know what time it is. You know how you lose track of time? And if you really have no idea if it's like 2 something or 3 something, you have half of the chance of it being 2 something and half of the chance of being 3, do you? No, wait. 2:45. So that means the 2 would only happen from 2:45 to 2:59, right? And the 3 would be from 3 to 3:45, so that's definitely not fair. Okay, so help me figure out if C is fair or not. What do you think? Should we select it or not select it? Did I put you to sleep, Chris?
Yeah, got it.
Should we select it or not select it? Ashlyn, what do you think? Should we select it or not? Anyone already done this one and happen to know? Okay, I'm going to select it and just give it a try. Okay, so that one is okay because it's a random time between approximately those 2 times, and so you theoretically have the same number of odd numbers and even numbers. Maybe I was overthinking that one. Okay, moving on. Julie's driving her 3 children to the pool. Each of them wants to sit in the front seat. The kids hand their mom 2 6-sided dice. One is red, one is yellow. They ask her to make a fair decision about who gets to sit up front. Mom rolls both dice. If the total is 6, Abby sits up front. If the total is 7, Cam sits up front. If the total is 8, Bobby sits up front. If their total isn't 6 through 8, she rolls again until she gets a total of 6, 7, or 8. Gosh, I feel like we suddenly need a chart of all of the possibilities of dice adding up to a certain number. So this could take us a minute to stop and figure this one out. Should we go ahead and do it? I don't know if you guys are doing your own thing or paying attention. How many of you want me to keep going through this particular little practice with you? That was a no to everyone in the classroom because no one raised their hand. Ashlyn, is this helpful for you? Have you already passed this one? Let me see. I think I've already done it. Okay.